So hi, and I'm Asya, and I have a question for you. Can you read the title of this lecture? Can you? Good. And how about now? Isn't it a little bit more difficult? So this is how I see it, blurry, and for me it's significantly harder to read this text. So hi again, I'm Asya. I have a bachelor's degree in computational biology and a master's in computer science. I work as an algorithm team lead and a developer at Evinst, which is a small startup based in Tel Aviv, Israel. And in my free time, I like traveling and hiking, and my love for traveling led me all the way to Antarctica a few years ago. But until this point, I haven't explained to you why I see blurry. And in order to understand it, we need to go back in time to the moment I was born. Because right after I was born, I didn't respond to light stimulations at all. And the doctors suggested I might be blind. After a while, it was discovered that I'm not blind, but I am visually impaired due to albinism. So what is albinism? Albinism is an inherited genetic condition that manifests itself in a lack of the pigment melanin. And melanin plays a crucial part in the development of the eye in the embryonic stage. And so people with albinism tend to have various visual problems, such as lazy eyes, crossed eyes, and many more. And in those embarrassing childhood pictures of mine, you can see some of those problems that I have until this day. So what does it mean to me to be an albino in my everyday life and to be visually impaired? It means that I struggle to read small text in print, and I often struggle to read text from the blackboard in the lecture hall, or even to read my own lecture notes when I speak in public. When I work on the computer, I usually enlarge all the fonts of the programs that I'm using, and I often struggle to find the font enlargement option in the programs that I'm using. Actually, just a few weeks ago, I discovered how to do that on PyCharm, like easily. And so it's really a struggle. And when I work with data, it's usually visual data. I work on computer vision problems. And often I struggle to make the right decisions for my research, and I tend to rely more on statistics and on the opinions of people around me to make the right choices for my research and my projects. However, my story is not unique. As of 2015, there were over 217 million people who were visually impaired in a moderate to severe level, and over 36 million people were blind. In total, over 250 million people over the world are blind. All those are visually impaired, sorry. All those people use technology just like anyone else, and there are various tools that help them to use technology, such as screen readers and magnifying glass software and many more. However, websites and mobile apps need to be built in a specific way in order for those assistive technologies to help those people get the full information in an intuitive and easy way. All those websites and mobile apps need to be built in an accessible way. So Evinst, the company I work at, focuses on digital accessibility. At Evinst, we believe that accessibility is the responsibility of the developers, and so we build tools and we help companies incorporate accessibility into their development process. And so we help companies all over the world make their websites and mobile apps more accessible to people who are visually impaired and to people with other disabilities. So until this point, I explained to you what it means for me to be visually impaired, and I hope that I convinced you that accessibility is an important subject. Let's now discuss a specific area and specific struggle that people who are visually impaired might tackle. And we'll see how I try to solve this problem and the solution I came up with in the end. So here we have two buttons. On the top, we have a button that is light blue with white text over it. And in the lower part, we have a button that is dark blue with white text over it. And so those buttons are identical in everything, except for the background color of the button. And the color contrast between the light blue background and the white text is not high enough. And so people who are visually impaired might not be able to read the text on this button. And if this button exists in a crucial part in the flow in a website, for example, if it's a button that is required, somebody is required to press in case they want to book a flight or a hotel, this means that this website won't be accessible to the people who have low vision, and so that might be a problem. But how do we know that some color combination of the background and the foreground text is not accessible? In order to understand it, we need to learn some photometric terms. So the first term is luminance. So luminance expresses the amount of light that is perceived by the person, and it is emitted from the surface. And if we normalize this luminance between 0 and 1, we have relative luminance. And this term can be used in order to calculate something that we call a color contrast ratio. And basically, we take two colors, the darker color and the lighter color. We calculate relative luminance for each of those colors, and we can get the color contrast ratio between those colors. And once we have this color contrast ratio, we can use a standard that exactly specifies what should be the color contrast ratio for two colors in order for them to be accessible and visible to people who are visually impaired. And so this is a standard, simple mathematical equation. And basically, there are many tools online that help designers and web developers calculate the color contrast ratio between the colors that they are using on their websites. And so this is actually a solved problem. Once you want to have some text overlaid on some constant background, everyone can check those two color combinations. If it passes the criteria that is specified by the standard, this means that this color combination is accessible and everything is good. But what happens if a text is overlaid on top of a complex background, such as an image or a gradient? In this case, the text can just blend into the background, and it won't be accessible or readable to people with low vision. And what people who work as accessibility experts do in this case. They just sample pixels around the text and calculate the color contrast ratio that I explained earlier. And so after doing that, they can assess if the text is accessible or not. However, there is no tool that is actually automatic and does that for them, and it's actually a task that is takes a lot of time, is manual and subjective. And this was my goal actually. I wanted to develop an algorithm that solves the problem of classifying a text overlaid on a complex background into a readable or a non-readable text. Okay. So when I started this task, I actually had some POC code that was developed earlier. And when I started working on it, I just tried to use the code that I had. And this POC code that I had relied heavily on OCR technology. OCR is basically extracting text out of images. And so this POC code, what it did, it planted text into images. And after that, ran an OCR engine called TESSERACT. And the OCR engine extracted the text out of the image, and it was compared to the text inserted into the image. If they were identical, everything is good. And the text was classified as readable. However, if they weren't identical, the text was classified as non-readable. Okay, sounds great, right? So I wanted to check this code, how it works on real data. The problem was I didn't have any data, and I had to collect it manually. Fortunately, I knew some JavaScript, and I built a scraper that collected images of text from the internet. And so I had pairs of text and images of this text, how it looks on websites. And after that, I applied the OCR engine that was in the POC code, specifically TESSERACT. And I wanted to see what are the results and what I'm getting. So this is an example of a text that is very clear to us. However, TESSERACT returned just blank. Weird, right? Here is another example. It's another image of a text that is very clear, very readable. And again, TESSERACT returns just gibberish. What is going on? So I tried to understand what TESSERACT is doing and how it's working, and I came to a few conclusions. So first, TESSERACT is an OCR engine that is meant for documents, for extracting text out of documents. How documents look, basically it's black text over white paper, and it's slightly different from the images that I had. Another thing that is nice about TESSERACT is that it has a Python wrapper, a really nice Python library that is really easy to use, and it's a great tool for prototyping. It supports many languages. It's another great advantage of TESSERACT. And it's actually easy to train for new languages or new characters. However, the cons that I saw for my task were that TESSERACT works on images that have high quality, over 300 dpi, whereas the data that I collected was 72 dpi, which was much less. In order to improve the results of TESSERACT, anyone can do certain image processing operations, such as turning images into black and white, or reducing noise. And those operations really can improve the results of TESSERACT. However, I was afraid that for my task, they might harm the classification. So I decided not to do it. Another thing that TESSERACT is slightly poor at is that it returns not that good results on small characters and small text. And it also sometimes fails on special characters, such as currency signs. So until this point, basically I tried to use TESSERACT OCR engine on the data that I collected. And I found out that it's not the right tool for me. However, I didn't give up on the possibility of using an OCR engine on my data. And I started searching online for other OCR engines. Luckily, I came across a post by Yann LeCun, who is one of the godfathers of deep learning and head of AI at Meta. And Yann LeCun recommends in his post an OCR engine called EASYOCR. And this is a tool that is based on PyTorch and uses modern deep learning algorithms. And so I decided that if Yann LeCun recommends something, I should definitely try it. So let's see how EASYOCR works. So first it gets an input image, then it applies pre-processing on it. Next stage, it detects text out of the image using a model called Craft. Please remember the name. We'll return to it later. After that, it performs a text recognition, and so it turns the characters or the text detected earlier into a sequence of characters. And in the last part, it basically decodes the sequence of characters into a meaningful text. So each part of this process is actually can be replaced by a different model. It's a very modular system. And it's let's see how it works on the examples that we saw earlier. So here we see that EASYOCR does a better job on those examples. But let's see two more examples. Here we see that EASYOCR makes mistakes on some of the characters, such as the S sign. It replaces it with a $sign, or it doesn't recognize well the percentage sign. And so let's see what I found out about EASYOCR. So the first thing is that EASYOCR is meant for detecting text in the wild. So TESSERACT works best, is meant for detecting text on documents, while EASYOCR detects text in the wild, which means that it recognizes text in natural scenes, such as street signs, for example. It's based on PyTorch, which I personally think is pro, but not everyone would agree with me. It's a really modular system. Each part of it can be replaced by a different module. And as its name suggests, it's easy to use, and there is a really nice Python package for that. The cons that I saw is that first, it doesn't work that well on black and white images, where TESSERACT performs well. And it makes mistakes on special characters, such as the percentage signs and currency signs. So until this point, basically, I tried 2 OCR engines in order to solve my problem of classifying text overlaid on top of an image into a readable or not readable text. And I came to the conclusion that neither of these systems works for me. And I tried to think how I can combine them, or maybe trying a different OCR engine, but I came to the conclusion that those systems might be too complex, and it might be hard to maintain and debug. And so at this stage, I decided to recalculate my route and to try a different perspective. So basically, the perspective I tried so far was trying to use POC code and make it work. And until this point, I learned a lot of things, and I decided to try my own, build my own system, my own code, based on the things that I learned so far. And so, as part of this perspective change, I decided to use 3 basic principles in my development stage. And the first one is splitting big problems into smaller problems. The second one is using only the relevant existing parts and not using big system just because it's there. And the third one is finding the right balance in my dataset to make the best out of my model. And let's go over each one of those principles. So the first principle is really simple. It's splitting a big problem into smaller problems. So we have here a text. It's written here, feel good. And by looking at this text, we can see that the text is not very clear, but it's hard to quantify. However, if we go over each one of those characters, for example, the E on the right and the O on the left, we can see easily that the E is readable and the O is not. And so if we go over each one of those characters, we can calculate the ratio of the bad characters and the ones that are not clear and not readable out of the entire text. And according to a predefined threshold, for example, if we decide that only texts that have 0.8 good contrast ratio out of everything, then the text is readable. In this case, this text won't pass, and it would fail our condition. So the next principle is using only the relevant existing parts for my problem. Until this point, I used OCR engines as black boxes, and when they failed, for example, when TESSERACT returned gibberish, it was really hard for me to debug and to understand what is going on. And instead of just using a big black box, I decided to use only a small part out of the systems that I tried. I decided to use the craft model, which is meant for detecting text. And so I used craft, which is a model that basically calculates for each pixel in the image the probability of this pixel to be in the center of a character. And based on this probability, we can build a heat map where the high probability would be the area where that are red, and in the areas that we have lower probability, the colors would be blue. And so we can extract out of the image the bounding boxes of the characters, and we can have small images of the characters in the text. And after that, the next stage is basically classifying all those characters into readable or not readable characters. And this leads me to the third principle, which is finding the right balance in the dataset. Basically, I model my this problem of classifying characters into readable or not readable characters as a binary classification problem. However, it's not actually binary, as we have some scale, where in one hand we have characters that are very clear and readable, and on the other hand we have characters that are not. And this scale is actually very subjective. Every person has their own scale, and people with low vision might have a different scale at all. So another thing that affects the problem when trying to label this data is that we sometimes have an effect that is called anti-aliasing. So what is anti-aliasing? It's basically a method of rendering on a screen. And when we talk about fonts and characters, basically it does some smoothing effect on the characters. However, when the characters and the font are very thin, it means that the color of the text blends into the background, and so it makes things look much worse than they are actually. And so when I tried using the label data that I had, that was manually labeled, I had a bunch of subjective labels, basically, and the model that I trained on this data didn't perform that well. So I decided to enrich the data set that I had with labels that were objective, that were labeled based on the standard that defines exactly what is a readable character and what is not. And I performed a series of experiments where I tried different balances between those two groups until I had a model that performed well and did well on the entire set. So how does the entire solution work? So first, it gets an input image and a text. Then it runs craft in order to extract characters from the text. Each of those characters is labeled and classified into a readable or not readable character. And after that, the bad contrast ratio character is computed. And in the end, based on a threshold, we classify the entire text, and we assess if it's accessible or not. So until this point, I explained to you how I try to use OCR architectures in order to understand if a text that is incorporated in an image is accessible or not. I tried different OCR architectures, specifically TESSERACT and EASYOCR, and I came to a conclusion that none of them is good enough for my task. And after much thought, I reframed the problem, and I developed my own system. And this actually led to a breakthrough and to a system that manages to classify texts well. And now it's a part of our product. Basically, Events has a product that is meant for scanning big websites of our clients. And one of the things that we scan for are texts that are not accessible, since they are overlaid on a complex background. And when I ran the system over over many websites, I found out that this is actually a problem that is more relevant for specific areas such as travel and art and design and news websites, things that are more visual. And here are some examples of texts that were detected as not non-readable. And you can see here that those texts are actually not very clear, not only to people with low vision, but also to people with good vision. And so this leads me to my last point. And in the beginning of the lecture, I told you that over 250 million people over the world are visually impaired. Solutions such as the one that I presented today can help them their everyday life. I ask you to think about how you can incorporate accessibility into your everyday life, either in how you write your code, or how you build your presentations, or how you create plots. And let's together make the world more inclusive for people with vision impairment and to people with disabilities. Thank you.
Thank Asya. Is there any question? Okay, I'll come with a mic.
Thanks. That was a really great talk. Do you have any advice for how to make things more accessible for people who are colorblind, particularly in data science-y type presentations?
Yeah. So actually, what I talked about, the standard is also meant for not only for people who have low vision, but also people with color blindness. So it actually incorporates people with color blindness. But basically, what I can say is that there are certain color combinations that just don't work. Everybody knows about like green and red. So basically, don't use them, but there are more color combinations that are not good enough. So basically the tools that I presented can be used for that as well. Like basically colors that have high contrast ratio, color contrast ratio would work. And another thing that I can suggest is not rely only on color for conveying information, but add something else, like text or some kind of effect that makes things more clear for people that don't recognize color that well.
Other question? Then I have a question. Oh, okay.
Hi, thank you for your presentation. I was wondering, what are the main challenges faced by visually impaired people who are browsing?
I'm sorry, I didn't hear.
Sorry, I was saying, what are the challenges faced by visually impaired people browsing the web today?
Oh, wow. There are so many challenges. I can't start for it. So the colors, of course, but there are also websites that are just too much, too much color, too much everything. Everything is popping. Yeah, so I always look on websites and I just sometimes think what people were thinking, because sometimes they are designers and it looks good, but when you try to look for the information you need, you can't. So basically that.
I wanted to ask you a question.
Yeah.
You said about EASYOCR that you thought that PyTorch is an advantage.
Yeah.
Why do you think PyTorch is better than other frameworks? What's your experience?
Yeah, so I have experience with TensorFlow and PyTorch, and basically everything in PyTorch is easier and simpler. So I think that's a better tool in general.
It's more about usability, less about models or pre-trained things or
I
whatever.
think that you can do like everything in both, but when you want to do something just that works simply and get things done, then PyTorch is better, in my opinion.
Any other question? Yeah.
Thank you for your good presentation. And I have a question. Do you think it's possible to do a further step that recommend a specific font color for colorful background?
Well, fonts it's actually like a full area, right? That there are so many fonts, and there are people that are just trying to understand which fonts are accessible and which are not. So I can't like tell you which font you should use, but generally there are fonts that are better, and you should like try and search what works out for you. I really invested time in like picking the right fonts and the right colors for my presentation. It took time. I, for example, used Quicksand, which is, I think it's okay. But yeah.
Then this is, I think we ran out of time. Thanks a lot, Asya, again for your talk.
Thank you.
And